Multiple choice. Which set of irrational numbers is in order from least to greatest? So it looks like all the numbers are the same. So I'm going to go ahead and approximate each radical, and that way it'll give me an idea of what the numbers are. So for radical 2, if I'm approximating, it's between radical 1 and radical 4. So I have between 1 and 2. So if I'm counting the spaces, 4 minus 1 gives me 3, 2 minus 1 gives me 1, it's approximately 0.3. So if it's 0.3, then radical 2 is approximately 1 point repeating 3. Radical 5 is going to be between radical 4 and radical 9. So the two whole numbers are 2 and 3. 9 minus 4 gives me 5. 5 minus 4 gives me 1. Once I divide that, I get 0.2. So approximately 2.2. This is my whole number, 2 and 0.2. Then we have 11. 11 is between 9 and 16. So 3 and 4. So with that said, we have 16 minus 9 to give me 7, and 11 minus 9 to give me 2. So 2 divided by 7 gives me approximately, we get 60, so let's go with 8, 56, 4 again, so 5. So I'm just going to approximate to about 0.3. So that's radical 11's approximately 3.3 since our whole number is 3. And then pi, of course, is 3.14. Okay, so let's take a look. I'm looking at this number, this number, this number, and this number. Now that we have decimals, can we figure out which one's the least to greatest? So go ahead and figure that one out on your own. Let's move on to 27. So we have tell whether the statement is true or false, and you're going to explain. So if I know that this is the answer to one side of the square, that means the area must be 0.36. So one way I can check is if I do 0.06 times 0.06 to get 0.36. So 0.06 times 0.06 gives me 36. And I have 4 zeros here. So I have 1, 2, 3, 4. So it looks like the decimal spot is not in the right place, so this one's false. And it's enough that I explained through my work here. Next one, 1.1 times 1.1 should give me 1.21. So that's 1, 1, 1, 1. So that's 1, 2, 1. So yes, that's true. And then I know that 20 times 20 definitely is not 40. So that's false, because 20 times 20 gives me 400. Okay. Tell whether a triangle with a given side length is a right triangle. Explain how you know. So we have to follow the idea of a squared plus b squared equals c squared. So I'm going to post it here to go ahead and give myself a little bit more room to work. So if I'm looking at this one right here, square root of 74, I want to figure out which one is my hypotenuse. So square root of 74 is between, let's go with square root of 81, which is 9. So then 8 is 64, which is 8. So since it's between, it's about 8 point something. I don't really need to know what that is because I know that 8 point something is bigger than 5 and 7. So I know that my right triangle right now, the C is definitely going to be square root of 74. My A could be 5 and my B could be 7, or it could be switched around, doesn't matter. So let's see if it works for a squared plus b squared equals c squared. So a squared plus b squared equals c squared. If I have 5 squared plus 7 squared equals c squared, I get 25 plus 49 equals c squared. If I add this together, I get 74 equals c squared. Remember, I don't want squared, I want just c, so c equals square root of 74. And both of these match. So it is a right triangle. For 31, you're going to do exactly the same thing. I know that square root of 2 and square root of 2 is smaller than square root of 3, and I know that 3 is probably the largest. So if I draw my right triangle again, I'm going to figure out that this answer is 3 equals c. I'm going to have one that's square root of 2, and b equals square root of 3. So I have a squared plus b squared equals c squared. Now this is one of my favorites because everything cancels out. A is square root of 2 squared. B is square root of 3 squared, and that equals c squared. So remember that these two cancel, and so do these. So I end up with 2 plus 3 equals c squared. Well, 2 plus 3 gives me 5 equals c squared. If I square root it, c ends up equaling square root of 5, which does not match 3. So this is not a right triangle.